Hello my precious friends, I really hope that you're doing great. Welcome to today's class. It's our 18th lesson on a given Form 4 mathematics topic called differentiation. So we are looking at our 26th example, which reads that a man has 75 pi square centimeter sheet of metal and wishes to make an open cylindrical container with it. Find the dimensions of the tin for which the volume will be maximum. So the key thing to note is what we are given and the type of the container that you are dealing with. So of course you are dealing with an open cylindrical container. So an open cylinder will roughly look this way. So if it is open, it means that one of the parts is of course closed and the other part is open. So I'll let the lower bottom to be closed, then of course the upper end to be open. Then we are given the area, that is square centimeters. These are units for the area. Of course, we know that for the cylinder, we usually talk of the surface area. Therefore, the 75 pi square centimeter is representing the surface area of an open cylinder. So, for the open cylinder, we know that the bottom part is circular. Therefore, we talk of the area of a circle, pi r squared. The upper end is also circular. We also talk of pi r squared. But because the upper end is open, we are going to ignore the area of the upper circle. Then the curved surface is always given by pi dh, or which can as well be given by, remember the diameter can also be given by twice the radius. So this can also be given as pi, then of course into bracket 2r, then we multiply by h, which basically will be equal to 2 pi r h. Therefore, if we want the surface area of an open cylinder, we are going to take the pi r squared, that is the area of the lower circle. Then of course we add the curved surface, which is 2 pi r h. So we're going to say that the area of an open cylinder, the area of an open cylinder is given by pi r squared plus 2 pi r h. Then of course we are told that the area is 75 pi square centimeters. So this should be equivalent to 75 pi, then of course square centimeters. So from this particular equation, we can make h the subject of the formula based on the variables given. So I can talk of pi r squared plus 2 pi r h being equal to 75, then of course pi. So I can simplify this equation by dividing through with pi, of course, which is common. So over pi, then of course over pi. So the pi's are going to cancel out. So this will cancel with that. This one will cancel with that. Then of course these will cancel with that. So we are remaining with r squared, then of course plus 2rh being equal to 75. So we can easily make h to be the subject of our formula. To achieve that, I'll take this one to the other side so that I'm having 2rh being equal to 75, then of course minus r squared. I divide through by 2r. I also divide through by 2r. I divide through by 2r. So of course the 2r and the 2r will cancel out. So that means our h will be equal to, if I take 75 divided by 2, of course I'm going to get 37.5, then of course over r, then minus 1 over 2 is the same as saying 0.5, so 0.5, then of course 1r, r here 1, r into r squared, I'm going to get r. So that means I'm going to remain with 0.5 r. So this is my equation for the h. So I can label it as my equation 1. Then we are told that find the dimensions of the tin for which the volume will be maximum. So clearly we need an equation for the volume of a cylinder. So the volume of a cylinder whether open or closed, is always given by the cross-sectional area multiplied by the height. Of course, the cross-sectional area is a circle, so that will be pi r squared. Then the height will just be h. Therefore, the volume of an open cylinder will be given by pi r squared h. The pi r squared, that is the cross-sectional area, then of course multiplied by the height. Remember, that is the general formula for finding the volume. You take the cross-sectional area, you multiply by the height. So this will be equal to pi r squared. Then of course, remember, we already have our value of h. So this will be into bracket. Our h is the first equation, which was 37.5. Then of course divided by r, then minus 0.5 r. Remember, I'm doing this just to express my equation in terms of one variable, which will be r, so that when it comes to finding the derivative, our work will be easier. So on opening this particular bracket, this is what I'm going to get. So I'm going to have pi r squared, then of course multiplied by 37.5, then of course divided by r. Then I'm going to have minus 0.5 r, then of course multiplied by pi r squared. I'm simply opening the given bracket. So on simplification, this is what I'm gonna get. So from this side, I'm going to get the following: the volume of the cylinder being equal to, of course, the radius here 1, radius into r squared, I'm going to get r. So that I'm going to remain with 37.5 pi r. So this one is giving me 37.5. Then of course we are having pi r. Then on simplifying the second part of the equation, I'm going to have 0.5. Then of course r multiplied by r squared, I'm going to get r cubed. So remember, from the laws of indices, a power m multiplied by a power n should give you a power m plus n. So also, if you have r multiplied by r squared, of course this is power 1. It means that it will be r to the power of, you add the 2 powers. So of course, which will give us r to the power of 3. So clearly, this one will give me minus 0.5. Then of course, pi r cubed. Minus 0.5 pi r cubed. So on getting that particular equation, now I have my equation for the volume, but the question was clear. It was stating that find the dimensions of the tin for which the volume will be maximum. Remember, we say that the maximum point or the minimum point or the point of inflation, which is basically a turning point, the derivative, the gradient function, at any given maximum point, the gradient function must always be equal to 0. So because we are talking of the find the dimension of the tin for which the volume will be maximum, it means that at V max, at the volume maximum, the gradient function, which will now be dv, then of course the other variable here is the radius, so we'll talk of dv dr must be equal to 0. That is at the maximum point. Therefore, it means that our d over dr, of course the v, we already have the equation for v, which is this one here. So the v is 37.5 pi r, then of course minus 0.5 pi r cubed. So this one should be equal to 0. So of course we are going to differentiate this equation with respect to r. Of course this is r power 1. So on differentiation, this is what we're going to get. Of course the variable is r, so the 1 will pre-multiply the coefficient. So this will give us 37.5, then of course multiplied by 1, then of course pi r to the power of 1 minus 1. So we subtract 1 from the power, then minus 0.5, then of course the power will pre-multiply the coefficient, so multiplied by 3, then of course pi r to the power of 3, we subtract 1 from the power. So this one should give us 0. So clearly this will simplify to 37.5, then of course pi, so r power 0, which will be 1, then minus 0.5 by 3, this will give us 1.5, then of course pi r to the power of 2 being equal to 0. So clearly this is 37.5 pi, because r power 0 will give you 1. 1 times 37.5 pi, you will get 37.5 pi. Then minus 1.5, then of course pi r squared being equal to 0. So we can see that pi is common. So I can actually take this one to the other side. I'll take this one to the other side, so that I'm having 37.5 pi being equal to, when it crosses equal sign, it becomes a positive. So positive 1.5 pi r squared. If I want to get the value of r, I'm going to divide through by 1.5 pi. I also divide through by 1.5 pi. So clearly these two are going to cancel out. The 1.5 pi, the 1.5 and pi. So of course the pi's will cancel out. So clearly radius squared will be equal to 37.5 divided by 1.5. Of course this will be equal to, so 37.5 divided by 1.5, your calculator is going to give you 25. So this is 25. So if r squared is equals to 25, you're going to take square roots on both sides. So I take square root and also square root on this side. Of course, the square root should give you a plus or minus. So clearly our value of the radius r will be equal to plus or minus 5. Then of course the units was square centimeter. So these are radius, so it will be centimeters. But we know that radius is a scalar quantity. Therefore, you're going to ignore the negative part. Therefore, our r will be equal to 5 centimeters. So that is one of the dimensions. So of course the other dimensions for finding the volume was the h. So clearly we still have our equation for h here. We had said that the height h was equivalent to, so this was 75. If I pick it from this particular part here, I'm having 75, then of course minus r squared. This was divided by 2r. I'm simply picking it from this equation here. It's the same as saying 75 minus r squared over 2r. So on substituting my r, I'm going to have 75, then of course minus r squared, that will be 5 squared, divided by 2 multiplied by r, of course, which is 5. So this will be equal to 75 minus 5 squared, that is 25, 2 by 5, that is 10. So this will be 75 minus 25. Your calculator is going to give you 50. Then of course divide by 10. Therefore the h will be equal to 50 over 10. This will give us 5 centimeters. Therefore the dimensions that will make the volume to be maximum are r being equal to 5 centimeters and h being equal to 5 centimeters. So these are the dimensions that will make our volume to be maximum. Then we check example 27, which reads that Onyango wishes to fence a rectangular research plot using 100 meters of wire. One end of the plot has a wall already erected. Calculate the maximum area he can fence. So of course we are given the wire is 100 meters. Then you are told that the Onyango is fencing a rectangular research plot. So rectangular, it means that this is the shape. The shape is a rectangle. Then you are being told that one end of the plot has a wall that is already erected. So I'm going to let the end that is being erected to be this one. Let this side to be already erected. So of course that means that we'll have the width and the length. So these three sides, this one, and this are the ones which are yet to be erected. Then he wishes to fence a rectangular research plot using 100 meters of wire. So it means the 100 meters of wire is the one which will be surrounding these three sides. So it will be moving this way from here to here, then of course to here. So it means that the perimeter from this particular point to this point will be equal to 100 meter. Remember, distance around a figure, that is the definition for the perimeter. Therefore, we'll say that the perimeter of three sides of a rectangular plot will be equal to, so of course three sides will talk of width then plus the length, or we can talk of the length plus width plus the other width, because the other length is already erected. That is why we are not including it in our calculation. So this one must be equal to the 100 meters. So this is 100 meters. So clearly this can be written as length plus width plus width. This will give us 2 width, which is equals to 100 meters. So clearly we can make length to be the subject of our formula. So from this formula, we can say that length will be equal to, our length will be equal to, I'll take this one to the other side. So length will be equal to 100 minus 2 width, 100 minus 2 width. So I can call this as my first equation. Then we are told calculate the maximum area. So clearly we need a formula for the area of the rectangle. So the area of a rectangle, because the shape is rectangular, the area is given by length multiplied by the width, which will be equal to, our length is 100 minus 2 width, then of course, which was our first equation, then multiplied by the width. So this will be equal to, if I open bracket, this will be 100 width minus 2 width multiplied by width. That will give me a width squared. So that is our area of the rectangle. Now they want the area to be maximum. We want the area to be maximum. We said that at the maximum point, or at any given minimum point, the gradient function must be equal to 0. The gradient function must always be equal to 0. So it means that at the maximum possible area, so we'll say that at a maximum, the gradient function, which will be dA, we differentiate at the first variable with respect to, the second variable is now w. With respect to w, this must give us 0. So clearly this will be d over dw. The area is given by this equation here. So this is 100 w, then minus 2w squared. This gradient function must be equal to 0 at any given maximum possible area. So this one is indicating that we need to differentiate. Of course, this is power 1. When we differentiate, we pre-multiply the coefficient with the power. So this will be 100 multiplied by 1. Then, of course, w. Then we subtract 1 from the power. Then minus 2 multiplied by, of course, the power will pre-multiply the coefficient. So we'll have 2 by 2. Then, of course, w2, we subtract 1 from the power. This must be equal to 0. So clearly, this is going to give us the following. So this will be 100 w, then 1 minus 1, of course, we'll get 0, minus 2 by 2, this is 4, then of course w power, 2 minus 1, that is 1, so this is equals to 0. A number to the power of 0 will give us 1, so this is 100, then of course multiplied by 1, which is w power 0, then minus 4w power 1 is equals to 0. So clearly 100 minus 4w will be equal to 0, and therefore our 100 will be equal to, I take this to the other side, this will be positive 4w. So I'll divide through by 4, divide through by 4. So clearly w will be equal to 100 divided by 4, which is going to simplify to 25. So our width is 25 meters. Since we already had the formula for the length was equal to, from the first equation, it was 100 minus 2w, which will be equal to 100 minus 2. Our w is 25 meters. So this is 100, then of course minus 2 by 25, that is 50. So clearly 100 minus 50, this will give us the length of 50 meters. Therefore, we have the dimensions of the rectangle that will make the area to be maximum. But the question wants the maximum area, not the dimension. So we'll say at a maximum, we are going to have length multiplied by width, which will be equal to Our length is 50 meters. So we'll have 50 meters multiplied by our width is 25 meters by 25 meters. You take 50 multiplied by 25, your calculator will give you 1,250 square meters. Therefore, this was the maximum possible area that he can fence. Thank you very much for accompanying me until the end of this particular lesson. I do not take it for granted. In case you are new to the channel, kindly hit the subscribe button and also turn on the notification bell so that whenever I upload a new video, you'll get notified. Until next time, this is Kind Tuition Academy. Thank you very much.